Hello, I just wanted to go over the basics of everything in these last two sections on AnalogRead, analogWrite, and System.out.print lines in the simplest circuits possible. So I've got 4 examples ramping up in difficulty, and here's the first. We've got a potentiometer here, like one of those little knob turning things. They're really easy to wire up. Well, first of all, let's wire up our board. We got 5 volts going to the 5-volt rail and ground going to the negative rail or ground rail. And then from there, for a potentiometer, we've got one end of it connected to ground, the opposite end of it connected to plus 5 volts. And then as we turn it, the middle pin will vary between 0 and 5 volts. And then we're taking the info from this guy using AnalogRead and using it to control the basically the voltage to the LED. Really, we're using pulse width modulation, which is kind of a poor man's equivalent of changing the voltage. Instead of going between 0 and 5 volts, we change. It's always 5 volts or 0 volts, but we just change the percent of time that this guy's on. He turns on and off a bunch, but we're just changing the percent of the time it's on or off to make it kind of equivalent to changing the voltage. And same way to hook up an LED as normal. We got a path from ground through a resistor, 220 ohms, through the LED, long end of the long pin for the LED, connecting it to a pin on the Arduino, one of the digital pins with the squiggle on it, in this case pin 9. That means it's capable of pulse width modulation. So that's the basic circuit. AnalogRead, analogWrite for an LED, and let's check out the code. Super long. We set up our LED to be an output to take down that resistor shield. That happens once in setup, and then loop, which happens again and again. We create a variable called pot for potentiometer and make it equal to the analog read value of pin A0, which is what we have the middle pin of the potentiometer hooked up to. So as this the voltage at that middle pin varies between 0 and 5 volts, and the analog read value of the pin on the Arduino it's connected to will vary between a number between 0 and 1023. So yeah, 1023 if it's 5 volts, 0 if it's 0 volts, and if it's say half, say 2.5 volts, it would be 512, and everything in between. And then we just take that number, and AnalogWrite's a little different than AnalogRead. AnalogRead can vary between 0 and 1023, which is 1024 different possibilities, or 2 to the 10th power for those math curious above you. AnalogWrite, though, only has 8 bits of precision. It's only 2 to the 8 possibilities. So it varies between 0 and 255, so 256 possibilities. Fortunately, 256 is just 1024 divided by 4. So we take this number we got from here, divide it by 4, and we get a nice perfect number between 0 and 255 to write to pin 9. And then when we run this sucker, the higher the voltage of the middle pin at the potentiometer, the brighter the LED. Assuming it's not lagging. That's it. Hopefully that guy makes sense for you. Let's try upping the difficulty a little. Here is our next one, which looks exactly the same. We still got the same potentiometer, the same LED. We just have slightly more complicated code because this time we're going to print out both our analog read value and our analog write power. We still have to set the LED pin to be an output, but now we also want to start the Arduino talking to the computer at 9600 bits per second, 9600 baud rate. And same thing as before. We read from the pin on the Arduino that the potentiometer is connected to, which is A0 here. And save it in a variable called pot. This time I created another variable holding the analogWrite power, which is, as before, the AnalogRead value divided by 4 to take our value between 0 and 1023 and convert it to a number between 0 and 255. Then we write that to the LED just like before. I could change this so it says power, and that would be the same, entirely equivalent. But then I got these print lines. Remember, if it's just Serial.print, it keeps printing on the same line, and then Serial.println for line will go into the next line after. So if you notice how this ends up printing out, it prints AnalogRead value exactly as stated because it's in quotes, and then we print the potentiometer value, our AnalogRead value between 0 and 1023. In this case, with the way I've got the potentiometer set up, that was 634. It's kind of middle-ish. And then it goes and prints a comma, a space, and then analogWrite power, exactly as is, because it's in quotes. And then it prints the value of the power variable, because it's not in quotes, so just equal to whatever it is. In this case, that's 634 divided by 4, rounding down, and that gets you 158. So yeah. I can change this. If I start this simulation, I can go and change my value, and this will be lower. This is about a quarter, so it should be about 255-ish. Probably a little less because it doesn't go 360 degrees. Yeah, 164. And that, when divided by 4, gives you 41. And notice it is not so bright. All right, that's it for that one. Hopefully the printing makes sense. Exactly the same circuit as before, except we just got to throw in a Serial.begin and setup, which is typically 9600 bits per second, unless you, for some reason, need a higher rate of communication, at which point you can change that. And then the Serial.print lines. Quotes around everything you want exactly as what's in it, and without quotes if you want it to print the value of that variable. All right, next guy. This is basically exactly the same circuit, only instead of a potentiometer, we are using a photoresistor, which if you check out the code, it is exactly the same for the moment. However, we're going to change it in a minute. Because the problem with this photoresistor, first let's look at the circuit. Photoresistor is set up in a voltage divider configuration, meaning we got two resistors, one connected to +5 volts, which is our photoresistor, which changes its resistance. It gets lower the more that light hits it. And we have another resistor connecting this middle point between the resistors to ground. And then as this resistor changes, so does the voltage at this middle point. The math is whatever this resistor is, the one connected to ground is, the percent that is of the total resistance, the resistance of that plus the photoresistor resistance at that light level, is the percent the voltage at the middle point is of the total resistance. If that doesn't make sense, just look up voltage dividers, and it's on the Google Classroom, or you can look it up elsewhere if you're wondering more on the math. Anyway, resistor connected to ground, resistor connected to +5 volts, and you've got just measure the voltage at the middle. That is all it is. Now, this is exactly the same code as before, but the issue we find ourselves with is if it's as dark as possible, ideally we'd want it at 0 volts. But if we go and look at our serial monitor, it's pretty low. It's 6. It's not 0 though. And if we give it as bright a light as possible, like shine the brightest light on it, ideally we'd want it to be as bright as possible, like 255. But if we go and look at our serial monitor, we're only hitting 169. So we are varying from 679 on the high end. That is the biggest analog read value we get when the brightest light. In this particular scenario, you will have to test this yourself and go through this exact same process and then make it as dark as possible and then measure what you're getting. In this case, we're reading 6. So we're going from 6 to 679. So the only difference I'm going to do is, instead of this nice little divide by 4 thing, I'm going to use a command called map. Now, map isn't as bad as you think. I just want to map the potentiometer value, which should range between 6 and 679. So take the name of the variable you're kind of mapping from one set of values to another set of values, and then enter the lowest value it's going to have, and then enter the highest value it's going to have, and then enter the lowest value you want the 6 to map to. In this case, I want it to map to a 0. And then put the highest value, the thing you want the 679 to map to. In this case, I want to map that to 255. So this is my input range, my actual analog read value. My pot should vary between 6 and 679 depending on light level, but I want to turn that into a number between 0 and 255. So that way, when I run this, notice at the low end, I've got an analogWrite power of 0, and it should be completely off. To a high level, it should be fully on and map to an analogWrite power of 255. So that's a nice trick just to max out your brightness if you're using photoresistors, and just, or some other sensor that you want to, that doesn't use your whole range. Anyway, last thing I want to mention is, what if I wanted to work with multiple LEDs? How could I do this? What is the simplest way I could make this work? Get it? So as it goes up, it changes the brightness of each LED in turn, and then eventually turns them all off or on. So to do that, it's just each LED is hooked up exactly the same way as the first one was, path from ground through 220 ohms through the LED and then to the pin controlling it. If I want to change the brightness of it, it's got to be 1 with a squiggle. So in this case, 6 has a squiggle, 9 has a squiggle, 10 has a squiggle, and 11 has a squiggle. So they're all capable of analogWrite, and so I can change their brightness. And then the potentiometer is hooked up exactly like before. One leg connected to ground, the opposite leg connected to plus 5 volts, and then measure the voltage at the middle leg. Here's my code. Set all the LEDs to be outputs to take down their resistor shield. In this case, I'm also writing to the serial monitor, so I got to throw in a Serial.begin with our typical 9600. And then in loop, every pass-through loop, I'm going to read from that potentiometer, get my value between 0 and 1023. And quarter of 1023 is from 0 to 255, or 0 or 256 possibilities. So if the potentiometer value is from 0 to 256 possibilities, I want all of the higher LEDs to be off, and my one LED to vary between 0 and 255, which, if this if statement is true, guaranteed this value is between 0 and 255. Else if it's kind of in the next quarter of possible values, I want to start turning on the next light. So in that case, if it's from 256 to just below 2 times 256, which is 512, I want to have the first light fully on, and I want the second light at a level equal to whatever my potentiometer value is. I want it to be 0 for if potentiometer is 256, and I want it to be 255 if it's 511, which is the highest allowed value. Right, 1 less than this guy. So all I'm doing is subtracting 256, and that just converts it into a 0 to 255 number for that guy, and then I want every light above it to be off. And then for the third kind of quarter of the range, I want the first two lights fully on, and then the third light to have a voltage level 0 if the level is 512, or 2 times 256, and 255 if it's the highest possible range, which would be 1 less than 3 times 256. So I just subtract off the 512 here, and that'll give me a number between 0 and 255 if this is true, to change the brightness. And I want my fourth light off, and this one I must be in the last quarter of the range of the analog read. So I want the first 3 lights fully on, and then I want to turn my last light to some brightness depending on the potentiometer, how far it is through the last quarter of the range. And so I just take my potentiometer value and subtract 3 times 256, which is my starting point. Anyway, hopefully that made sense, and you're feeling a bit more confident about things. Thanks for listening.